Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on September 11th, 2025, which was about 2 days ago. The headline result is that off-the-shelf large language models, when paired with simple calibration and ensembles, outperform traditional verbal autopsy algorithms and lift both individual accuracy and population estimates. The paper is titled LLMs, Language Model Assisted Verbal Autopsy for Cause of Death Determination, and as we will see later, the deployment implications are quite significant. In short, the system blends GPT-5 prompts, Bayesian latent class modeling, text embeddings, and meta-learners to handle domain shift and make better use of free text narratives. On X, commenters highlight GPT-5 diagnosing causes of death with practical value, praise the mix of statistics and language models, and note 5 to 10% gains, with moderate engagement around 100 likes. Alright, the previous segment highlighted the pipeline. Figure 1 presents how each method scores across adult sites. The left panel shows top 1 accuracy, where GPT-5 generally leads, though PEMBA favors embeddings. The middle panel reports top 5 accuracy, which climbs markedly for all methods, so rankings converge. The right panel displays CSMF accuracy, and calibration lifts population estimates without changing top N, which matters for health planning across sites. So the previous figure contrasted individual accuracy and population estimates, and Table 1 now quantifies the calibration effect on CSMF by site. The table reports raw GPT and calibrated GPT alongside LCVA, which allows a clean population level comparison. Calibrated GPT leads in most sites, for example AP at 0.85 and Mexico at 0.83, while UP still favors LCVA. The adult mean rises from 0.73 to 0.77, showing calibration improves population fractions without changing top N. Well, the previous table quantified calibration gains, and this table illustrates the prompt design that drives the language model's judgments. The layout shows role instructions, task steps, and an allowed causes list, which constrain outputs so the model stays on label. Guidance lines encode clinical heuristics and timing cues, because neonatal causes hinge on hours and days after birth. A few shot example anchors the format with demographics, questionnaire, narrative, and a one-line rationale that links symptoms to a single cause. Alright, the previous table outlined the prompt mechanics, and Figure 3 presents neonate performance by site. The left panel shows top 1 accuracy, where GPT-5 reaches roughly 60 to 80%, with Bohol and UP near the top, because only 6 causes make distinctions clearer. The right panel reports CSMF accuracy, which climbs above 0.9 in Bohol and UP, indicating strong population estimates. Embeddings and ensembles track closely, so the language model remains the strongest single component. Alright, the previous figure covered neonates, and Figure 2 presents child performance across sites. The left panel shows top 1 accuracy, which spans roughly 30 to 60%, with GPT-5 usually leading and PEMBA standing out. The middle panel reports top 5 accuracy, which jumps above 70% for most sites, so method differences shrink. The right panel shows CSMF accuracy, reaching up to about 0.77 in Bohol, and calibration elsewhere yields small, consistent gains. So, 2 takeaways stand out. Off-the-shelf language models, paired with simple calibration and lightweight ensembles, beat classic verbal autopsy tools on both top 1 accuracy and population fractions, and free text narratives materially boost performance. The implications are practical triage and better mortality surveillance across sites. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.